The next video is still applying properties of logarithms. We're going to apply them in a different way. So this is the final way that they're going to try to get you to learn your log properties. We're going to contrive some problems to work the other way, and I'll show you how we can do this. So we're going to use the same methods we use to expand logarithms that we can use to condense them. So we're basically going to be using these rules kind of in reverse of what we've been doing them before. So let me try to explain what I mean by that as I work through this problem. So in this problem, we're supposed to condense it. Last time, in the very previous problem, they had it all condensed and we expanded it. So we're going to put this back into the simplest form under one common logarithm that we can, only our logarithm of base 2. So some of the things that I see the negative 5 sitting out front, in front of the logarithm. That means I must have used a power property on that, because the log of the power is the power times the log. So I could reverse that. I'm talking about this rule down here. What we're seeing is this part of the rule. It's the power times the log, but we want to convert it back into this rule where it's the log of a power. So the first thing I'm going to do is I'm going to rewrite this as the log of base 2 of x plus 1. Notice that's in parentheses already. That's your argument. We want to raise that to the negative 5 power, and that's that power rule that we're using only in the reverse way, where we're saying since they're equivalent, I can go this way as well as I can go this way. Before we've been going, if it's a log of a power, we write it as the power times the log. But this time we've got the power times the log, we want to write it as the log of a power. So just a little bit of semantics there and how we're going to use it. We can use it either way. And the same thing occurs in the second part. So plus, it's a log of base 2. I see a number times a logarithm. So it's a power times a log. I can rewrite it as 6x raised to the third. Okay. Now that's one of the things that we can do to it. We use the power rule. The next thing I'm going to do to this, I can see that there's a couple things here that I got to deal with. This negative exponent is one, and the other one is the fact that we're adding. I'm going to attack the addition first. The only time that we add logarithms and we add exponents, because keep in mind, logarithms are exponents. If we're adding exponents, that means we have to be using a product property. It's this one that we're using, and we're going to apply it in the backwards or in the reverse direction. So rather than taking the log of a sum, we can write it as the log of a sum is the log of a product. So log of base 2 of the argument x plus 1 raised to the negative 5 times the 6x raised to the third. So we're using our property in the kind of, like I said, to me it's a little bit of the reverse way, because we've been so focused on going from the log of a product to the sum of the logs, and now we're doing the sum of the logs can be written as a log of a product. There's a couple other things that you want to be able to work with this. This is a log of base 2. I want to rewrite this statement without that negative exponent. So here's what I'm going to do with it. Since I know what negative exponents can do, it's going to reciprocate the base. Now this is x plus 1 over 1. We reciprocate that base, so now it's 1 over x plus 1 raised to the 5th power. We want to take that times 6x cubed. And now I can use the power rule on these. This is going to be 6 cubed times x cubed. Remember, the power rule says anytime you have a power outside of parentheses or a power raised to power, it's 6 to the first times x to the first. You can raise it's 6 to the 3 times 1 and x to the 3 times 1. So now we have an expression that looks like this, and this is all over 1. The final little simplification I'm going to have on this one is a log of base 2 of. I'm going to multiply fractions. I'm going to go straight across. Well, 1 to the 5th power, maybe an intermediate step here, is 1 to the 5th power is 1, and x plus 1 to the 5th power is x, so I use the power rule of exponents there. But 1 to the 5th is 1, so it's just 1 times 6x cubed, and 6 cubed is 216, so I'm simplifying 6 cubed times x cubed all over, and what we have is our argument of x plus 1 raised to the 5th. Now this is condensed as far as I can get it. So we're applying these properties maybe in a little bit of a reverse direction concept or idea. So I'm going to move this off the side here so we can still see it. But we want to condense this expression. Now what I see is a subtraction, and I see another subtraction. So when I see two subtractions, I'm thinking that's got to be a division rule here. What I would like to do with this one is I'm going to leave this 3x plus 5 alone. Since I see two subtractions in a row, I like to think of it as, and this is what I'm going to do, is I'm going to factor out a negative, and what I get is 4 times the natural log of x plus the natural log of x minus 1. Now, put my bracket on the end. What I've noticed is that since there's two negatives there, I'm going to factor out that negative, and now I can deal with an addition rule instead. And that's what I would really prefer to work with anyway. So I got the natural log of 3x plus 5 minus the quantity. Now I've got a power rule that I can use. Remember that if it's a power times a logarithm, we can write it as the log of the power. So it's going to be the natural log of x to the 4th plus the natural log of x minus 1. Now I'm going to use another logarithm property, minus. When you see addition, think of adding exponents. If you're adding exponents, you must be using the product property. If we're adding logarithms, then it has to be the log of a product. So the sum of the logs equals to the log of a product. So the natural log of, we got x to the 4th times x minus 1. Now, going to the next step, I see a subtraction. Whenever I see subtraction, I think here's an exponent, there's an exponent. Whenever we subtract exponents, I need to think of the quotient property. The difference of two logs is equal to the log of the quotient. So we're going to rewrite this as the quotient of 3x plus 5. Since I'm going to put in a fraction bar, the parentheses are no longer needed since they're implied grouping symbols as soon as I do the fraction bar, of x to the 4th times x minus 1. And I suppose there would be some people that would say you can distribute the x to the 4th. Typically they don't, so that's probably what they end up with in most cases, but there's no reason why you couldn't say this is x to the 5th minus x. So either form, but here's our argument in each of those, and that is condensing them rather than expanding them like we did in the previous one. So lots and lots of practice on those rules, trying to get those reinforced and integrated into your mind and how you can use them.